Okay, so here's part I, the graph. So key things that they're going to want to see. They're going to want to see that your axes are labelled, that they're labelled V and T. They're going to want to see that the graph starts at T and V equals 0. And they're going to want to see that this is a straight line for stage 1, that the velocity, the constant velocity that it reaches is capital V, and that you've got a constant deceleration. They're also going to want to see that the gradient of the stage 3 bit of the graph is going to be less steep than the gradient of the stage 1 bit of the graph. Now, I've put the times T1 and T2 on the axes, the time axes, to get ready for part 2. Now, the information you then have is that the acceleration of the first stage is 0.4. So stage 1. What you're going to do is you're going to use the information that you've been given in stage 1. So you know that your initial velocity u is 0, that the final velocity of stage 1 is capital V. I've chosen the time to be T1 and the acceleration is 0.4. So I'm going to put that in the formula, V equals u plus AT. And what happens there is when I substitute them in, I get T1 is V over 0.4. And of course, that is the same as 2.5 V. So the time of the first stage is 2.5 V. I'm now going to do, and which is a bit more challenging, stage 3. Now, stage 3 is the final stage of the journey where you're decelerating. So what I've done is I've called the time at the start of that stage T2. Obviously, the end time is 250. So the time that stage is spread over is 250 minus T2. It's that difference there. So what I'm now going to do is I'm going to use SUVAT. I know that for stage 3, the initial velocity at the beginning of stage 3 is capital V. The velocity at the end of stage 3 is 0. The time taken, as we've just explained, is 250 take away T2 seconds. And it's decelerating. Because it's decelerating, that's a negative acceleration. So what I'm then going to do is substitute that into the V equals u plus AT. And of course, this is what I'm then going to get. I'm now going to rearrange that to get an expression for T2. So I take everything over because I'm not enjoying that being negative. I then divide everything by 0.08, so I get 250 minus T2 is 12.5 V, and that is my time 2. Right, I'm now going to label the graph with those times. So I've got my first time, which is 2.5 V, I've got my second time, which is 250 minus 12.5 T squared. What I'm now going to do is I'm going to work out the time over here. Now I know that if that is 250 minus 12.5 V and this is 2.5 V, this is going to be 250 minus 12.5 V take away 2.5 V, which simplifies to be 250 minus 15 V. So what I've actually got is a trapezium. So I've now got and I know that the distance travelled, and I know that the distance travelled is 880 metres, and I know that the distance travelled is the area under the graph of a velocity time graph. So I've got a trapezium. This is simpler than finding the distance in 3 stages. I'm just going to find the area of a trapezium. Now, to find the area of a trapezium, it's half the sum of the parallel sides times the difference between them. Okay, so something you would have used a lot at GCSE. So it's a half, add up the 2 parallel sides, so you're going to have 250 plus 250 minus 15V times by V, so I've got that V there, equals 880. And that is the hard math done. All you're now going to do is, what I've done here is I've multiplied by 2. Okay, I've moved the V to the front just because I thought it was easier to multiply out. Expand that bracket. You've got a quadratic, you're almost there, you have been given a question, you know, they've shown you what they want. You spot that you divide by 5 and you've done your 6 marks worth of work. That's got you 6 marks. You're now going to solve this quadratic. Now, they're not bothered how you solve that. You haven't got to show detailed reasoning. So I've factorised it and I've used my calculator. So I've got 2 values for V, 88 over 3, which is like about 29 1/3, I think, and V equals 4. Now, only one of these is going to be valid, and you know from what we've seen so far, you're going to have to justify this answer. V equals 4 sounds pretty good, and it looks like it's going to give us sensible answers. However, if V is 88 over 3, if you substitute that into your 250 minus 12.5V, which was one of the times that you worked out, you actually get a negative value. You can't have a negative time here, so you make the decision that V equals 4.